Hi everyone, is my voice audible? Can you please confirm? Can you please confirm if my voice is audible to you? Hello, thanks for joining and thanks for confirming. I will just wait for a few minutes because I will start the quiz when some more people join. Okay, maybe they are getting the notification and things like that. So we will just wait and then I will start. Okay, meanwhile, you can ask your questions, anything that you have. And also you can share the URL with people. We will be having a very interesting live quiz now. Okay. So you can share the URL with people. We will have a live quiz and then we can see the leaderboard and things like that. Okay. So you can share the URL with people who can join with us in the quiz. I'm doing good. Thanks for asking. How are you? Okay. So we have some more people joined. Thanks everyone for joining. I hope all of you are doing good. Thanks everyone for joining. So what I'm going to do is I'm going to share my screen in Zoom and I'm going to tell you what is the agenda for this meeting. Okay. So let me share my screen in Zoom. And let me go to the quiz page. Okay. So I hope you are able to see the quiz page now. Hello. Hi, everyone. I'm doing good. I'm doing live after some time. So I hope all of you are doing good. And this is the first quiz for this season. We are going to have a lot of quizzes. And the format remains same. Format is very simple. You have to simply go to a website or the app, slido.com. And in that app, you have to enter this number. Once you enter this number, then you will enter in the quiz. Okay. So I will just click here. And if you join the quiz right, then your name will show here. Okay. So what you have to do is very simple. You have to go to a website called slido.com or maybe a mobile app. And once you enter, right, you are inside the quiz. Just keep joining, guys. If we have more people, it will be a lot of fun. And as I told you, it will this time we have the theme based quiz. Okay. So we will have theme, and on basis of that, we will have, I mean, it will not be multiple areas in one go. It will be one area in one shot, and then we will discuss into that. And if needed, we can have a detailed discussion on that topic, and then we can go on to the next topic. Okay. So please keep joining, guys. More and more people join. It will be great because we have 15 questions. So you can think of this like 3 sets of five questions. Okay. In a moment, I will tell you what the theme is for today's quiz, and then we will start. Okay. But first, keep joining, keep joining. I see some 20 people in the live, but I see only 3 here. Please go to website called slido.com. Just enter this number, or maybe you can scan this also. Okay. Thanks, Rafi. Hope you are doing good. All of you are member of Unfold Data Science since very long time. Himanshu, I know you personally. Yes, also. Raj, Manikandan, Gayatri, thanks for joining everybody. Please keep joining, and please you can share the link with some of your friends if they want to join, because together if we have more people it will be more fun, right? Let's give few minutes for others to join. Maybe they are new to this platform Slido and they don't know how to join. Let's give few minutes and then they will join. So the format remains same basically. I will present a question to you. You will get 60 seconds. So what happens sometimes is my screen runs little few seconds lag behind, or you can say there is a difference between when you will see that in your phone and when I will present in the screen. Okay. So just to cover that 10 seconds or 5 seconds of time, right? I have kept 60 seconds for every question, but the question can be answered very well in 40 seconds or 45 seconds. Okay. So what you will get 60 seconds for every question. Once you answer, then we will see who has answered how much. Okay. And then we will talk about that for a minute or so, and then we will go to the next one. Okay. So I just want few more people to join, at least 10, so that it will be fun. Okay. So more people can join. Please keep joining, guys, or share with your friends who can join. Hi, yes, thanks for joining. And even if some more people don't join, we will start in a couple of minutes. Okay. And I will just disclose what the theme is for today's quiz. So the theme for today's quiz is optimizers in machine learning and deep learning. Okay. I find this topic really interesting, and the reason for that is very simple. Optimizers are something that is always slightly confusing for people, little mathematical in nature, and very much used in all the deep learning, machine learning kind of models. Okay. And one more important reason why I have kept optimizer as the theme is you can expect a lot of questions in this area in your interview. Okay. So let's see how much we know the optimizers and where are the confusion points, and obviously we can remove those confusions. Okay. So I'll be asking you 15 questions from optimizers itself. I'll just give one last minute. If anybody wants to join, you have to simply go here, scan the barcode, or go to Slido, and you will be in the quiz. Okay. I just don't want anybody to come after one question and they will feel like it's not justice to them, right? So let's have everybody go through all 15 questions. Okay. So I think I have 10 to start with. And if somebody comes later, maybe they will join. Okay. So let me start the quiz, guys. As I told you, 60 seconds for every question, and then we will discuss the answer. So let's start. The theme is optimizers. Okay. Here is the first question. Okay, 7 seconds, 6 seconds. Let's see what people are saying. Now the answer will display. Okay, I was sure there is going to be a lot of votes for AdaGrad, and I was sure there was going to be a lot of confusion between option B and option C. Okay, so let's talk all these options one by one. Option A is stochastic gradient descent. There is no question of all these things. Okay, so SGD is not at all an option. We will talk about B and C because people are confused between B and C. But Adam has more to do with decaying weight and things like that. I mean, Adam is something more advanced, more things are there in the Adam, not only um, adapt the learning rate for each parameter by considering the average of past squared gradients. Okay. So I know there is a confusion between AdaGrad and RMS prop. If you go and read about these two, right, there is only a slight difference between these two. Past squared gradients is applicable for both. Okay. Past squared gradients is applicable for both, but one of these is taking average and another of these is taking sum. Okay. AdaGrad is the one which is taking sum. RMS prop is the one which takes average. Here the question is about the average. Okay. Hence, in this case, RMS prop. This is the next question. Okay, okay, okay. Let's see what are the two things Adam is combining. So Adam is combining basically, I don't know how you are saying RMS prop and AdaGrad, because whenever we talk of Adam, right, anywhere you read about Adam, you will see that Adam is combining the benefits of two things. One is called RMS prop and other is called momentum. So if you see how the optimizers are working, right, you will see the very basic optimizer that all of us, very basic plain vanilla optimizer is nothing but gradient descent, right? If you include something in the gradient descent, that becomes nothing but a momentum. So we can talk more about it. After gradient descent, just to avoid the oscillation and just to avoid the uh, trap in the local minima, we use momentum. So momentum is a different way of looking at things altogether. Okay. And then comes the concept of uh, different learning rates for different weights. So in a weight matrix, right, different learning rates for different weights. That concept comes in adaptive gradient and RMS prop. Okay. So in one way, we can think of adaptive gradient and RMS prop similar family of optimizers. Okay. But momentum does something very different. Okay. So if you see AdaGrad, if you see Adam, right? Adam, what is the job of Adam is it takes best out of all optimizers. Okay. So it takes momentum piece from momentum. And since AdaGrad is a better in this family, RMS prop and AdaGrad, so it takes momentum and AdaGrad basically. Okay. So in this case, not RMS prop and AdaGrad, but momentum. RMS prop and AdaGrad are more or less slight difference only. Okay. But if you read about Adam includes uh, momentum way of working basically. Okay. So in this case, option A. Okay. Momentum and RMS prop. Sorry, momentum and RMS prop. So RMS prop is the more advanced. I mean, better than this one, AdaGrad basically. So not AdaGrad, momentum and RMS prop. Okay. This is the next one. In this case, if you see, right, it is telling which optimizer maintains a moving average of gradients and the squared gradient. So at the moment, it will, it is, it says of here, it is talking about combining two functionalities. Okay. So it is telling moving average of the gradients and squared gradients both. So at the moment we are combining the best of two, right? It has to be Adam. Okay. So in this case, only 17% people are saying Adam, but where in ADA grade do you see both these functionalities, or where in RMS prop do you see both these functionalities? If you go and read about Adam, right? I mean, in Adam, basically what happens is Adam tries to take the, if you consider this part, right, moving average of the gradient. So what it tries to does is it tries to absorb the momentum piece of the things. Okay. And from the squared gradient part, right, it tries to absorb the RMS prop side of it. Okay. So here it is combining best of two worlds. So in this case, like the way we discussed in the previous one also, right, it has to be a Adam only in this case. What is the primary purpose for using momentum in optimization? Okay. So this one, I'm happy that many of the people have given the right answer only, because there is not lot of doubts in what is the use of momentum. So momentum is basically one addition on top of plane gradient descent. Okay. What momentum does is momentum simply tells to gradient descent or stochastic gradient descent that, hey, don't waste your time in, you know, oscillation in one point, or don't waste your time in the direction which is not helping you. Okay. So it simply tells converge faster and keep moving in the direction of where you should move for the steepest descent. Okay. So momentum is simply telling accelerate gradient vectors in the correct direction. So in this case, this is the right answer. 83% people have told. Let's see the next one. Okay. Let's see what are people saying here. So again, there is some confusion. So actually what happens is these kind of topics, right? It may not be fresh in your mind. Okay. So sometimes what happens is people forget, and this many optimizers are there, right? So sometimes you will forget what this was doing actually. Okay. So no problem. I will tell you, Adam optimizer basically deals with two kinds of moments. Okay. They call it first moment, second moment, right? So in first moment and second moment, right, beta 1 and beta 2, they simply control the exponential decay rates of those first and second moments. Okay, and both these things together control how your learning rate changes. Okay, so how Adam is built is using two moments, first moment, second moment. Beta 1 and beta 2 will in a sequence control the exponential decay rates for these moments. Okay, and these two together, what it will do, it will simply go and see how my learning rate is decaying. Okay, or how my learning rate is changing. So let's see the answer here, what people have said and what this is correct. Now let me go and see the leaderboard once. So Rafi comes on the top with very less time, also significantly less time than others. Then Alex, then Balaji and Nirav is there and Himanshu is there. So that's great. Okay, we are going great. And we have finished 1/3. Now 2/3 is left. You can just ping in the comment how you are liking the quiz so far. And if you're live in YouTube, you can do that, how you are liking the quiz so far. And then we go to the sixth question. Okay, so I know this topic may not be fresh in your mind. So what I plan to do is from next time, I will announce the theme in the beginning only. I mean, I will give you some time to brush up those concepts about those themes. But anyway, surprise tests are also good, right? So I'll just give 30 seconds of time if people are commenting something, and then I will open. I'll go to the next one. Okay. Thanks, Yash. Thanks, Alex Tech Project. Siva Charan, thank you. Okay. And let's go to the next sixth question that will come on your screen now. This is a simple one. Okay. Here also almost 60% of people are saying NAG, which is the right answer. So what NAG does is it is slightly different than other optimizers that we normally work with. Okay, so this optimizer is unique in a way that it anticipates the future position of the parameters, and there is a look ahead mechanism in this. Okay, so in this case, this one NAG is the right answer for this because it is simply asking for look ahead mechanism. Let's go to the next one. Okay, so in this type of question, I did not expect a lot of confusion because option D is anyway not useful at all because you can simply throw it out. Option D, stationary gradient. Why we will bother about any of the optimizers also, right? So problem with sparse data or problem with dense data. So these two, sometimes RMS prop will help in one of these scenario, but mostly RMS prop is used in this scenario where you have rapidly changing gradients, right? Where your gradients keep changing and sometimes it inflates, sometimes it deflates, right? In that kind of scenario, what RMS prop will do is it will bring stability to your convergence. Okay. So in this case, option C is correct. Okay, so here the right answer for this is answer C. It helps in reducing the learning rate as training progresses, and there is a reason for that. So everybody will explain you optimizers using a mountain example. So if you are a mountain climber, if you are a hiker and you are on the top of a mountain, you want to go till the lowest point, right? Then what direction you should move to? So if you think, forget machine learning, forget mathematics, forget everything, right? If you think how it should happen in real world, right? What should happen is initially you want to take long steps, okay? Because it is clearly visible that in this direction, if I go, I'm going to a lower level, okay? Once you reach to the lower level, right, then you have to be very careful on you are not overstepping the lower level. So which means that how in that lower level, right, how do you ensure that you are at the minimum, the global minimum? How do you ensure that? For that, if you start from the beginning, initially you need to have the large step size, and when you are converging in the end, right, you need the small step size. That is what is provided by learning rate decay. Okay, initially large step size, once you are close to the convergence, then small step size. So it helps in reducing the learning rate as training progresses. Okay, this is one question which we have discussed before as well. I think it should be easy for you. Yes. See, there is an improvement from SGT, then how some of the people are saying SGT, I'm not sure. It clearly says which optimizer modifies is the standard stochastic gradient descent. So how you can say SGT here? It says modifies the SGT, right? So I'm not sure how you are saying option A. There could be confusions in these three options, but how option A you are saying, I'm not sure. Anyway, so between AdaGrad and RMS prop only, I see a point of confusion, because Adam is something which is more complex in nature, which is a combination of multiple things. In between ADA grand and RMS prop, as we discussed in the beginning, one of that is kind of average and one of that is sum. Okay, so here, uh, as you can see, RMS prop is the right answer for this, because it is talking about exponentially weighting moving average of the squared gradients. Okay, so question 10, last one for this part. Remember at Anil, how do I participate? You have to simply go to a website called slido.com and enter this number. Okay, or you can have Slido mobile app, enter this number, or you can scan this code. So in this case, what you have to think, why ADAGRAD came into picture. Okay, the name itself is ADAGRAD, that means adaptive gradient. Okay, and the reason this has come into picture is because of your system or your input data having multiple features of different natures. For example, one feature, let's say I'm trying to predict whether some transaction is fraud or not fraud. Okay, I have 1000 variables, 1000 x1, x2, x3, x4, x1000. Some of these features may have more important, maybe some of these features may be less important. Okay, the the learning of the system, right, learning of the model will also depend on which feature is holding how much of information. Suppose some feature is not useful for model for learning purpose, right? That feature, the deviation or the change or the shift of values, right, in terms of weight, I'm saying, it will be very small. For some features it could be very large. Okay, so when you have a sparse data and when we have a many features, right, some of the features have very limited information, some of the features have more information. What could happen is your ADA grad will, the adaptive gradient nature of this optimizer, right, it will help you a lot. Okay, so the funda of ADA grad is very simple. It is adapting the gradient based on how your feature is. Okay, and in sparse data your feature are of various kinds, various types, and many features, of course. So in this case, option B is right. And high dimensional data, people are saying, I can agree with some extent to this as well. But here I am choosing only one option in this case. So option B, if I have to choose one, right, I'll go with option B. So we have completed 10. Let's see the leaderboard ones. Rafi comes on the top, then Nirav, then Nirav Satani, then Krupali, then Balaji, and then Alex. Okay. So Nirav, Krupali, Balaji, Alex all are 6 out of 10. Rafi is 7 out of 10 and significantly less time. Again, I mean, time of response is very low, which is excellent actually. Okay. So with that in mind, let's move to the part 3 and then we will see the final leaderboard. So good job, Nirav, Krupali, Balaji, and Alex also. Let's move to the next one. Let me see how many people are playing now. Okay, I'll just see when I go to the next question. This is the next question. 20 people are there in the quiz. Very nice. Keep playing. Okay, so let's start eliminating the options first. Option A, nobody has said, so I am taking it this is not something to be discussed also. People are saying option C, ADA grad accumulates the sum of squared of past gradients, whereas RMS prop using a moving average. In my view, this is the right answer for this. But let's see the other options. RMS prop uses the same learning rate for all parameters. So is this right? Is this right? Then what is the use of RMS prop at all, right? So this is one thing that 25% people have answered. Okay, this we can we cannot answer this one. And then this is basically flip. C and D are flip of each other. Which one is sum of squares of past gradient and which one is moving average? So just to keep it very simple, ADA grad is sum of squares and RMS prop is the moving average. Okay, so in this case option C. So C and D are basically same, just the flip is there. So C is the right in this. A and B are not correct because it is talking about same learning rate. Okay, in this case, I'm sure there could be some confusion because not many of you would be aware of this one. NAG momentum, NAG optimizer. The reason for that is whenever you would have learned about that, maybe that time you would not have seen this one. Okay, so basically it is very simple to understand. Here the correct answer is option C only. Okay, and what happens in this is written here only. It is a variant of SGT with momentum, where momentum is adjusted using the gradient of loss function. And there is on top of this, right, there is a concept of look ahead, as there was one question related to this, right? So with the concept of look ahead and with this what I have highlighted here, right, this energy works. Okay, so in this case, right answer is energy. Okay, so here all these questions that we are doing now is basically one answer correct. Okay, it's not multiple things you have to choose. So what is the one thing that is most important out of these four things is what we have to choose. Okay, it converges too quickly. That is not right about SGT. It is computationally expensive. Sometimes yes, but why it is computationally expensive, or what is the one major drawback or advantage of this due to which the adaptive gradients have come into picture? Adaptive gradients have come into picture only because SGD has a tendency of getting stuck in local minima. Okay, And hence I'm happy nearly 75% people have said it right only. So it can get stuck in local minima is the problem here. Okay. And adapting learning rate is not there in SGD. I'm not sure how people are answering option D. SGD, there is no adaptation of learning rate in plain SGD. Okay, so option C here. Okay, so here I'm happy that people have said 0% of people have said option A and option D. I'm very happy because these questions are nothing but a way of checking the fundamental concepts. Okay, and at the moment fundamental concepts are cleared. I'm not much bothered about sum of gradients or squared of gradients. I'm not much bothered about minute difference between RMS prop and ADA grad. Okay, just the fundamentals should be clear. Okay, here are the 5 optimizers, what it does at high level. Here you are saying Adam is simpler to implement. Of course not. I'm happy nobody has said that. Adam requires less memory. Of course not. I'm happy nobody has said that. In between these two options, Adam always converges faster than SGD. Not necessarily. Okay, it can happen. Most of the time it can happen, but there is no you know statistical evidence, or there is nobody can say that it will always happen. Yes, it is meant to happen like that, but will it always happen like that? We can't say that. Okay, always is the keyword here. So the only one option and the right option is Adam adapts the learning rate based on first and second moments of the gradient. So as we were discussing, there are two moments of gradient in Adam, first and second. Adam will simply adapt the learning rate. Okay, and last but not the least, and after that we see the final leaderboard, and after that I take your feedbacks, and after that we plan for the next session. Let's see the last one. Okay, so most of the people are saying Adam, which is the right answer in this scenario, and the reason for that is when we are talking of non-stationary data, right, and that too in a deep learning scenario, right, we do not know how our gradients will behave, how our weight adjustments will behave. Okay, we do not know that. So better we take care of the vanishing exploding gradient problem, and we take care of the faster convergence as well. And if you want to have a master optimizer, okay, which takes care of all these things, then obviously Adam is your master optimizer, which will ensure that you don't get stuck in local minima, you converge faster, you take care of your exploding vanishing problem, you take care of your, proper optimization. So Adam wins in if you look of combining multiple things together. So in this case, Adam. So we have completed. Now let's go ahead and see the final leaderboard. Okay, congratulations, Rafi. I think you have answered everything in 5.58. Last season also, when Rafi participated, he was the one you winning most of the times. Okay. So congrats, Rafi, one more time. And Krupali, well done, Krupali. You are also just 8 minutes. You have answered 10 right questions. Alex, Balaji, and Nirav, all of you have done great. And now we can also see the for all the people actually. So here we can see for all the people whoever participated. For example, after Nirav, right? So Abdul is there, 6/15. Gayatri is there. Then Jay, Himanshu, Vikash. Okay, Arav, Siva, Amrit, Prashant, Anil, Yash, Raj, Rakshit, and Virendra. Okay. So now there are few things that I want to keep it here. First is whoever has won, right? What I can offer to you is, as I told you, there will be some rewards for this season. So you can simply go to unfolddataScience.com, whichever course you like. You just tell me that you want a coupon code for this. I give you a massive discount of, let's say, 80% on that course. You just write to me on unfolddataScience.com, my email. Okay. Rafi, Krupali, and Alex, all three of you are eligible for this. Whichever course you like, I can give you a massive discount on that. Okay. Second thing is, what are your feedbacks? Do you want me to announce the theme for going forward quizzes 1 week in advance? So how I plan to do it is every alternate Sunday, okay, around same time. For example, this Sunday we are doing, so next Sunday we want, and after that alternate Sunday, okay, around same time we can do. And if you want, I can announce the theme in advance so that you can be little prepared. But one thing is, if you bring in some more people, your friends, then it will be great, because now we played with 20 people. Imagine if we play with 100 people, right? It will be a lot of fun. Okay. Some of these concepts can be, everybody forgets. Being very honest, I also forget. Everybody forgets because these are a little mathematical in nature, right? So I mean, how much you can remember, right? So if I tell you in advance, maybe that will be helpful for you. Okay. Uh, so I am getting suggestions saying tell it in advance, and Siva is saying don't announce, keep it as a surprise. Rafi is saying in advance. So what other people say actually? Let's see the votes of everybody. Puspendra is saying he missed the quiz because of some work. Okay, fine. Give me the vote for, do you want me to advance? Do you want me to announce it in advance, or do you want me to keep it a surprise? Because both has its own advantage and disadvantages. So give some votes in the comment section. What should happen? Okay, Himanshu is saying 1 day in advance is fine. Anil is saying next week do on ML. I only know ML. Fine. So we will have easier topics as well. This time I know it was slightly on the higher difficult side, and it was intentional because I want people to not be too comfortable with things, because nowadays, a lot of competition is there in the market, right? So you have to be on your toes. Okay. Hence I will keep bringing something difficult, but I can of course keep something simpler as well. Okay. No, now I can't reveal, Alex. Okay, so we can do two things. One is I can reveal to you what will be the theme of next quiz 2-3 days in advance, or I cannot tell you at all. Okay, so maybe I can do a poll on the channel and I can take that decision, not a problem. With that in mind, I'll see you guys in the next quiz. Okay, meanwhile, keep subscribing, keep liking, keep sharing the channel with people, and keep learning, and I'll see you again in the next quiz and in the week with some video tutorials. Okay. Thanks everyone for joining. See you all in the next quiz. Bye. Take care.